This lesson is going to focus on the kind of the nuts and bolts behind a parabola, the geometric definition. What really makes a U-shaped graph thingy technically a parabola? Not every U-shaped thing is a parabola. It has to have specific characteristics, kind of like a circle. A circle is all points equidistant from a fixed point. So you have a point, and then you go and you mark all points that are the same distance, that distance called the radius, you get a circle. A parabola has a definition like that too. It's a little bit more complex than that, but that's what our topic is today. Technically, the skills you need to find today are what are the focus and the directrix of a parabola. So let's figure out what those are and how to find them. First of all, it's a special curve shaped like an arch. But like I said, not every curved thing, not every arch-shaped thing is a parabola. If it's going to be a parabola, it has to follow these characteristics. It is an equal distance from a fixed point, which we call the focus, and a fixed straight line called the directrix. Meaning, that directrix is always going to be horizontal right now. Later in the semester, we'll turn that directrix vertical, which will make the parabola open up side to side. But for now, we're going to make all of these functions, which means that they will all open vertically. So take a straight line and take a dot. All right, just any horizontal line, put a dot somewhere near it. All points equidistant from the directrix and the focus, from the line and the dot, form the parabola. So like this point right here. Why is this point part of this parabola? Well, it's part of the parabola because this distance, however far that is, and when you measure to a line, you measure at a right angle, right? So the distance straight up to the directrix is the same distance to that point. So you just keep tracing those points forever in both directions, and you end up with a parabola, all right, equidistant from the point and from the line. So you need to remember that definition. So skill-wise, what we need to do is take a parabola and figure out what is the equation of that line and what are the coordinates of that focus. All right, it's not that difficult of a skill. Let's start with this one. The key to this entire video, the key to your happiness and success is 1 over 4a. Remember 1 over 4a. Okay, so really if you're trying to find the location of those things, you're trying to find a distance. Okay, you're trying to find the distance from here to here, which is the same as the distance from here to here, because that vertex is just one of the infinitely many points that's the same distance from the directrix and the focus. So if we find that distance, and we already know how to find a vertex, we just add and subtract that distance, which is 1 over 4a. We add and subtract that, and we have our directrix and our focus. So let's see how that works with this example. These are going to count on the parabola already being in vertex form. So you might have to put it into vertex form, but that's fine. You complete the square. You've done that recently. So put it into vertex form if it's not already. We are already in vertex form, and our A is very nicely marked 1/4. So the key, the distance from the vertex to the directrix and the vertex to the focus is 1 over 4a, where a is 1/4. All right, 4 times 1/4 is 1. 1 over 1 is 1. So that distance is 1. This one's nice and easy, worked out smoothly. We'll do another one that's not quite as smooth, but that's it. All right, so let's figure out what this parabola looks like. Its vertex is at -2, 4, right here. Okay, we learned that because you go opposite, then you go left 2, up 4. This thing opens upward, and it has been vertically shrunk by a factor of 1/4. So it's a little bit wider than a typical parabola. But what I know right now is that the distance from the vertex that I just marked up, you know, this thing's going to be opening, let's see, think it's going to go through about like that. I'm going to go up to find the focus, and I'm going to go down to find the directrix. And how do I know that that's where they are? Because I just found that one right there. All right, that distance, said that a little awkwardly, but that distance right there is 1 because 1 over 4a equals 1. So knowing where my vertex is and knowing that that distance is 1, I've answered my question. What are the equation of the directrix and the coordinates of the focus? My focus, the point, kind of in the middle of the curve, the equations of that are -2, 5. All right, my vertex was -2, 4. I went up 1 from that to get -2, 5. My directrix, 1 unit below, and I'm going to express this, the equation of a horizontal line. A lot of people mix up y equals and x equals. A horizontal line is y equals, and like I said, we're doing all vertically opening parabolas, so your directrix, this unit, should be y equals some number. Y equals 3 is the coordinate of that purple dashed line. All right, so go to your vertex, figure out this distance, add and subtract that distance to get these locations. That's it. Easy peasy. This one's the same idea. It's just with that 3/4 in the front, it's a little bit more awkward. Let's find the vertex. X minus 1 squared, the opposite of -1 is +1. Then I've got a +3. Here's my vertex. It's opening downward. It has an A value of 3/4. That value, the fact that it's negative, doesn't really come into play when I'm doing my calculation, my 1 over 4a, because I'm going to add and subtract that distance. I'm going to go up that much and down that much, so it doesn't really matter. I just want to do 1 over 4a, where in this case a is 3/4, giving me, cancel the 4s, 1/3. All right, so I just need to move 1/3 of a unit. And you'll notice that these distances are often pretty small on graphs that we can actually deal with. I need to move 1/3 of a unit up to get my directrix. Remember, this opens downward, so the focus is here, 1/3 of a unit down. The directrix is here, 1/3 of a unit up, and the parabola goes something like that. I didn't get that 3/4 perfectly, but it's going to go something like that. All right, so what are the coordinates of the focus and the equation of the directrix? Focus, all right, in this case, I need to subtract. I was at a height of 3. I was at 1, 3, and now I'm 1/3 of a unit below that. So I'm at 1, 2 2/3. Do you agree that that's 1/3 of a unit lower than 3? Or another way to say 2 2/3 would be 8/3. And my directrix is going to be a third of a unit above the height of that vertex. The height of the vertex was 3. All right, think of 3 as 9/3. Directrix y equals 10/3. All right, up 1/3 to 10/3, down 1/3 to 8/3 for the focus. And that's it. All right, quick one here. We've got how to find focus and directrix. 1 over 4a is the key. Make sure you know what these things are, how to find them, and now you know all the good stuff about what makes a curvy-shaped graph truly a parabola. I hope this info has made your day. Young out.